Today you will see a practical demonstration on how to use JUnit, Mockito, and Cobertura. To start off with JUnit, I will be using the IDE IntelliJ. Our goal at this point is to create a Maven project and perform simple unit tests using JUnit. The very first thing you need to do is to create a new Maven project. You go to New Project, select Maven, the project SDK, press Next, and you give it a name. JUnit test, for example. You press Finish, and then you have your new Maven project. Now what you need to do is to add the JUnit dependency. To add the dependency, this is the dependency for JUnit. Now a button on the right side appeared. It's to load the Maven changes. If you go on the external libraries, you will see that the JUnit libraries are not there yet, and that's why you need to reload the Maven project. If you don't have the button, you can also right-click, go to Maven, and reload project. In Visual Studio Code, it should be on the bottom left corner where you have the Maven section. Now the JUnit libraries were added, and you're now able to perform unit tests. The only thing that's missing now are the actual Java classes and the task classes. Let's create a simple Java class. Go to Source, Main, Java, and you create a new Java class. Let's call it Calculator. This class has, for example, one method that calculates the addition between two parameters and returns it. Public int add, int a, int b, and return the addition of both. Very simple method. What we want to do is to check whether this actually works, because it might actually be wrong. In this case, since it's simple, we know that it's right, but in more complex projects, you might not be sure. So you can either right-click, go to Generate, Test, and create a test class for the calculator this way, or you can do it the manual way, and this time not under main, but under test. It's very important that you separate the test classes from the actual Java classes, as that is the default convention for it, and you put them in the same directory. So in this case, you have main Java and the calculator. So what we want to do is create the calculator test class under test Java calculator test. Calculator test is also the default naming convention that we use. Basically, calculator, the name of the Java class, and you put test behind it. So we create it. Now we want to create a test case. So to create test cases, before that, we need to create a calculator object. So private calculator, new calculator. And at this point, we create a test case. Test cases are annotated by add test. You press enter and it will automatically add the import for the test annotation. And under the test annotation, you create your method. Public void, it doesn't return anything. Add 2 and 2, for example. This is a specific test case that we want to make. Basically 2 plus 2. Check whether 2 plus 2 returns the correct result using the add method in calculator class. So the result is basically whatever the add method calculates. Might be right or might be wrong, we will see. And then what we have to do is to check whether this equals to 4. We know that 2 plus 2 is 4, and we want to check whether the result here using the add method is equal to 4. To do that, we use assertions. Assertions is also a part of the JUnit libraries, and you can import it with this import static org JUnit Jupyter API assertions, and we can add the star at the back to just use everything. Now if you write assert, you will see immediately assert equals. Assert equals compares the expected value to the actual value. If both are the same, it passes. If both differ, it fails. So in this case, we expect 2 plus 2 to be 4, and the actual value is whatever the add method returns. So assert equals, we expect it to be 4, and the result was the actual value. Now we created our first test case. How do we run the test case? You can see these two buttons on the left side. Here you can either run the specific test case by pressing here and run, or if you go next to the class declaration, you can see the other button to run all the test cases inside this class. If you press it, it will give you a nice view if they passed or failed. You can see that this test case passed. Another way to do it is to type maven test, and then you get the default textual display that you usually get. So one test was run and build success. None of them failed. Now, how do we automate the testing process? It is possible to integrate JUnit into a continuous integration pipeline. For this part of the demonstration, we will be using GitHub and Jenkins. I prepared a GitHub project that I cloned onto my machine. So if I go to Open Recent, it would be this project. It's very similar to the one before. Does the exact same thing, just with 2 test cases. Now, on Jenkins, you will need 2 plugins. If you navigate to Manage Jenkins, then Plugins, you go to Available Plugins. You can type Pipeline. I've already installed it, so it's under installed in mine. I can quickly look it up. It's this one, Pipeline. You can, under available plugins, select it and then install it. Same thing for Git. So you install Pipeline and Git plugin here. After you install them, you can now create a pipeline, and in this case, if we create a new job, go to pipeline, you give it a name, for example, JUnit pipeline, press OK, and now you scroll down and you want to use the pipeline script from SCM. This basically goes retrieve the Jenkins file from the GitHub repository. You still need to choose the Git repository. So in this case, it needs a repository URL. You go to your GitHub repository. You can press here and copy the URL and paste it here. And in this case, we need to change master to main, since the main branch is called main in this case, if you look here. The Jenkins file is also here, so it goes retrieve this Jenkins file. You save. And what you can do now is just build. If you build it, what it does, it does checkout SCM. That basically means it goes retrieve the pipeline script from the Jenkins file. In this case, the pipeline script has two stages: the build stage, does a Maven clean compile, and the test stage. This is the important part, the Maven test, to run the test cases. Go back, this is the stage view. You can add the plugin for that in Jenkins. And you've got the checkout.cm, retrieve the Jenkins file, the build stage, and the test stage. They all passed. Now, if you, for example, go to your project and make a mistake, let's say you do the multiplication instead of the addition. I added a mistake, I select it and commit and push. Now, if I reload, there's 49 commits instead of 48. It got committed. If I build this now, the test stage will fail. Yeah, if you go on to the build console output, you will see more information about it. You've got the same textual display as I've shown you before. You've got the test cases. 2 tests were run, 1 failed. Build failure. Where did it fail? At calculator test at 4 and 15. They expected 19, but it got 60. Now we've got 2 test cases this time though. What happened is that our first test case adds 2 plus 2, in this case 2 times 2, which is the same result. That's why you would need multiple test cases, and some that test, for example, edge cases, or by using extreme values, for example. So now if we go to configurations, we can even make it more interesting. For example, pull a CM. What this does is that it runs the build, the pipeline build, only if there was a change in the GitHub repository. So for example, if I type this, what this does, it goes check every 2 minutes. It's very excessive, but it's one way to show you. For example, at this time, it will trigger automatically only if there's been a change to the GitHub repository. So as I've just added the mistake, if I remove it again, there will be a change on the GitHub repository. Commit and push. If you go check the GitHub repository, 50 commits now. It's now pending. So without me having to press anything, it started the build automatically as it detected a change in the GitHub repository.
So I will be talking about Mockito. First off, for Mockito, you have to go to the pom.xml file to go to the dependency and add it there. Now I have one example that uses a database. Here we have two classes. One is data processor, as you can see here, and then data service, which has the fetch data, which is basically there to get the database. And then in our data processor test, here we have the code. First off, we have to stub the data service interface. We create the data service stub. We mock the data service class. And now this is the most important part of all of this, is to stop the behavior. So when data service stub.fetch.data is called, it should return mock data. And here basically we stopped the database. So we fooled the system, the program, that this is a real database. And afterwards we create the data processor instance with this stub service, data service. Afterwards, this is to perform the test. So we create the variable result. Afterwards, we have such equals, which will come from JUnit, which we will compare Mockito data with results. And if we test it, you can just go here on the test. You can see down here on the test results that everything is okay. So this and this is the same.
I'm going to explain to you cobertura, which is the third and last part of our presentation in this video. So starting off, I'm going to show you how you can access all the information on cobertura, and that is all documented within the official cobertura GitHub repository. So if you go to the URL of github.com/cobertura/cobertura, you will get this page right here with all the code that explains how cobertura works. And if you scroll down, you get into the README. And in the README, you have information that is quite useful. Here, for example, you have the dependency that you can use to integrate cobertura into your code, into your development with Maven. So if we switch to Visual Studio Code, here I have an example program that Kevin has explained before, and if we look, it is exactly the same with the calculator, so you should already be familiar with it. And if you see here, since it is a Maven project, I can go onto the pom.xml file, and within that you can see that, scrolling down for a bit, here I have integrated cobertura into the plugin, into the POM with the plugin. And as you can see here, it says a dependency, which you can also do, but I preferred using a plugin, which also works, by the way. If you wish to know where you can access that one, I was able to find this one on the website called beldong/cobertura. So beldong.com/cobertura, and you can find the plugin right here, and also some explanations about it. Right, so back to Visual Studio Code. Now that we know that I have indeed installed the plugin into the POM, I can then close this window, and as you can see, we also have the tests, which have already been explained here. So let's say that we wish to visualize which methods we have tested and integrated any unit tests, or where that is still missing, whatever. We should be able to use the command mvn and then cobertura : cobertura, and once you hit enter, you can now see, let me just enlarge this for a bit, that after a while, and if I scroll down, you will be able to see here, and you can see that it has run the tests, seen which tests work, which don't, where some are missing and whatnot. And after it says build success, you can see that nothing opens, nothing happened really, but where it actually all went down is within the target here. Within the target, you here have the site, sorry, not site. You have this, inside the target, you have this generated folders, which are all made from the cobertura that you have just made here. As you can see, cobertura, so it has just been generated by it. And if you go through it for a bit, you can find in one folder the .html file, which is the website that has been made by the cobertura generation. Here you can see the index.html. This is the one that I have been looking for. And once you copy the path, you should then be able to open a browser. I'll use Safari, but you should be able to use any browser you wish. Then after typing file, : you can then paste your path after that, and after hitting enter, here you can see the result of the generated website that we've just gotten from the command mvn cobertura. And here you can see the line coverage, the branch coverage, and however you whatever you will need. And if, let's say, we only had one method covered, and then you would be able to see it here as 1 out of 2, for example. So this tool is great to visualize what you wish to do with your code, and what you still need to do with your code, which unit tests you still need to put in, which methods haven't been tested yet. And so it's great to keep an overview of everything that you still need to implement to have an actual steady coding a great development environment with everything that has been tested, so that you can be sure that there will be no bugs at all. Just pay attention, because cobertura has not been updated since 2015. So you will have to switch to a 1.8 JDK or 1.9 at the latest. And nothing above works. So if you really wish to use cobertura, keep in mind that you will have to switch to a 1.8 version of JDK. And if you do not want to use an outdated tool like cobertura, which is understandable since it has been last updated since 2015, you will be able to use, as an example, JCoco for introduction purposes. So if you use JCoco, it is a similar tool that does the same thing and gives you coverage. And here you can see how similar it looks to cobertura, as I have just shown you. So if you do not wish to downgrade to a lower JDK, you can use JCoco instead of cobertura, which I also recommend, since it is way easier to use and you have a lot more documentation on it.